Hey everyone, this is Mayur. Welcome back to MLWorks. In this video, we'll be talking about MLFlow with Optuna. Optuna is an open source hyperparameter tuning library which helps you to tune your parameters of the model. Okay, so why do we need to do hyperparameter tuning in the first place? So consider you have a machine learning model and the algorithm has many hundreds of parameters to tune. Okay, and if we go ahead and check the combination of these parameters, the specific values, it would be like overwhelming if you want to do it manually. So what you have to do is you can use tools like Optuna, which will help you to tune those parameters efficiently with efficient searching techniques. Okay, so that's one of the reason why you have to go forward with tools like Optuna for hyperparameter tuning. So with that, what we'll also talk about is, since there will be hundreds of runs happening, okay, since there are like tens and twenties of what parameters you have, each capable of having range of values, so there will be hundreds of runs that will be taking place in the backend when you are trying to find the hyperparameter for your specific model. Okay, so it takes time and it is like iterations will be happening in the backend. So you want to capture everything, okay, to track them and evaluate them. Okay, so to do all those things, you have to capture everything, all the iterations that you are doing with Optuna. So for that, what we do is we integrate the results of all the iterations on MLFlow, so we'll be able to understand which parameter is giving the best model for us. Okay, so with that, what I'll do is, so we'll start off with there are a bunch of things in the scope of the video. Okay, we'll be starting off with the data preparation, which is like loading the data set, turning that into a data frame, and segregating into X and Y and train test split. So all those things. Then we'll be adding certain features which will be like important for model monitoring. For instance, you will be tracking the performance of the model, and you will be looking at the residual, that means, okay, and also feature importance, and as well other things, right, that we can go through in the video. And then we'll be integrating Optuna with the MLFlow, and we'll be analyzing the results once the hyperparameter tuning is done. So first thing, right, I'll just clear this and we'll start MLFlow here, MLFlow UI on the port 5000. So it will start the MLFlow. Now once this is starting, okay, what we'll do is we'll talk about the first thing, that is data preparation. So I have training.py. I'll just go through that. Okay. So first step is, okay, first importing all the packages that are required to play with all the different aspects like hyperparameter tuning, creating the data set, and then plotting the data set again. Plotting means plotting in a sense to understand the residuals or feature importance through the plots. Okay. So that is there. Let's first we import all the packages that are required and certain functions that we have written in separate files. One is plots file, and there is MLFlow API, which will be helping us to create or get the experiment name or experiment ID. And there are plots for understanding the correlation between the features and the target variable, and there is plot for feature importance, and there is plot for residual, which is the error, where the difference between the estimated and the ground truth. So this is with respect to the import statements, okay, till the line number 15. Next, what we do is, since I'm running MLFlow UI on port 5000, I'm just setting the tracking URI in the file. Set tracking URI as localhost 5000. And now, so we have created we have started the MLFlow. Now we want to create an experiment. Okay, for that we can just use this function get or create experiment, which I have written here in the MLFlow _ API. So under this, if you see, we are using the MLFlow's API, okay, which is get experiment by name. You will send the name and you will see if that name exists or not. If it is already existing, it will go ahead and fetch the corresponding experiment ID. And if it is not present, then it will go ahead and create the experiment. So that's there, and we have done till here experiment, and then we'll be getting the experiment ID here, and we'll be setting it to the set experiment. So this is where you will be creating an experiment, and then we'll be setting the experiment ID to set experiment. Next step is the data set, how to load the data set. So here, if you see in the line number 10, from sklearn or data sets, we are importing the fetching California housing. This is housing price detection, not detection, regression problem, which is a regression problem. What will be the potential price of a specific maybe a data points, right? What will be specific price for the specific data points? There will be certain features like latitude, longitude, median income, and median age of the house. So all those, based on those features, you will be identifying what will be the price of the house. So this is the data set. Okay, we just load it, and then we segregate the features, which is data, and then target, which is the median house value. Okay, so that will be our target. Now what we do is we combine both of them here. Okay, using NumPy's head stack, we'll combine together, and we have to reshape it into matrix. So we have give this -1, 1, and then we combine it together, feature and target, and we get our values. Now we have our feature names, and then which is again we have to df of feature names, it will give us the feature names, and df target names, it will give us the target name. Now we'll create a pandas data frame using these two values, right? Values and these two variables. So values are nothing but all the values of the specific data set, and here the column names of the specific data set. And then we were creating x and y. Okay, x is nothing but we have to just drop the target names, that is our x, which is nothing but features. Y is nothing but our target variable, which is median house value, that is our y. Now here we have something called as a correlation plot, which will be identifying how the features are correlating with the median house value with the target variable. This is the plot. Okay, if I go here in the plots, so you will be seeing in the plots, first thing, right, it's the median plot residuals, this feature importance. So yeah, plot correlation with median house value. So what we do is we find the correlation of all the features against the median house value, and then we sort it, and then we just plot it. Okay, so this is something just for visualization of correlation between features and target. Okay, now this part is done, 37 line number. Then what we do is we segregate our data set into x and y, and that all again like validation and again train. Okay, and we then pass it to D matrix, which is XGBoost format of loading the data. Okay, we convert our existing data, data frame NumPy arrays into D matrix, which is a specific format handled by XGBoost. So we convert to that, and it will help us in if when you are applying XGBoost model on top of this data, it will be using functionalities provided by XGBoost model on top of this data. Unless if it is not in this specific format, you won't be able to apply those special techniques which is provided by XGBoost. So first we have to convert that into D matrix, and then we have to apply the features provided by XGBoost on top of this D matrix. So it is there, D train and D valid is present. Now comes the part where you are talking about Optuna. Okay, so when you are trying to perform hyperparameter tuning, it will be generating bunch of logs. Okay, so you have to ensure that you are not confused with all the logs that are coming up. So you would reduce the verbosity of your logging to error only. Whenever there are some errors, that logs will be coming up. Okay, we are reducing that. That comes the part of champion callbacks. So here what will we do is, so when we want to see some changes are happening, right? So as your hyperparameter tuning is running, okay, there will be, when a specific parameter is turned on, okay, there is change in performance. Okay, it is increasing by certain percentage. There is an improvement in performance, and you want to notice that. Okay, so you want to calculate what is the percentage change that is happening after a specific parameter has changed. So for that, we can do something called as setting the winner, which is nothing but an attribute. Okay, whenever there is a best value comes up, right, a best value or best error score. Okay, so if a best score comes up, we turn that into a winner and we update it. Okay, and once that winner is updated, we want to understand by how much margin, okay, the value has got updated or the performance has improved. So this is taken care by this champion callback, where we are like, if there is a winner, we want to understand what is the difference between the winner and the previous best absolute value, best value, and then we want to check the percentage change that is happening, and we'll be notifying that. Otherwise, we'll just go ahead and do with the next set of parameters. So this is with respect to tracking the change in performance of your model, or if your trial rate, whatever the trials that is running, the iterations that are running, you want to check how much performance is changed based on the parameters. Okay, we'll keep track of that using this specific method. Now comes the part of objective function, the whole point of what you're trying to achieve with Optuna. Okay, so we want to do something called as finding the best parameters for your model. Now there are a bunch of things, right? There are a bunch of parameters that are present in XGBoost. Okay, one, for example, there is a booster parameter which can be GB tree, and there is a booster parameter called dart. Okay, these two parameters are there, then you have to tune these parameters. If this parameter is selected, then you can modify these parameters. Okay, if these parameters are not present, dart or GB tree, then these parameters no need to be then no need to tune these things. You can just tune all these other hyperparameters. Okay, so these are some basic global hyperparameters for XGBoost. Okay, where you can select among these three, and that is RMSE, squared error, and then lambda alpha value. So all these things are there. But once you select GB tree, then these hyperparameters are available for you to tune. Okay, so these are some set of parameters that we are declaring that we need to hyperparameterize, and then we are training the model, then predicting the model, evaluating the model, and then the most important step is you want to log everything. So you are logging the parameters, you are logging the metric, which is mean squared error, which is root mean squared error. So all these things have been tracked and stored in MLFlow. Now this is one part, which is the objective, what you want to achieve, and this is what understanding when the change is made, we are able to track it or not. Okay, this is champion callback. Okay, and then we have something called as our experiment, how it gets started, right? So how to get started with Optuna first of all. So you have to create a study for Optuna. If you want to perform parameterization, hyperparameterization of variables, what you have to do is first you have to create a study, and you want to minimize the loss. Okay, so that's the direction we have to go towards, and then we want to number of trials that we want to run through on this specific objective, that is the loss we want to reduce, that is our objective overall. And we are also attaching the callback. We want to understand what is the change in performance when there is certain parameters are changed. So we want to understand that as well. That is our callback. And this is the number of trials that we want to do. And what we want to optimize is this specific objective function. Okay, this is the two key statements with respect to Optuna. Okay, one is the creating study, and then what you want to optimize in that study. Next is again we are keeping track of the parameters, then again MSC, RMSC, and then we are setting certain tags for that particular experiment that we are doing. And then here we have a log of fit model instance XGB trained. So what are the best parameters that we have, or we find out the best parameters, then we perform training again, and then we again evaluate the models on that specific parameters. Okay, in this case I am finding the best parameters, and then I'm training it again. Then I want to log everything. Okay, as a file. In this case, correlation plot is nothing but correlation between the features. Okay, between features and the target variable. Then we want to understand the feature importance of the specific whatever, right? The model has picked certain features. Okay, it has to understand what is the importance of each feature on that specific run. And then we have something called as plot residual, which is for understanding the change in or difference in between the estimated and the ground truth. This is the plot for that. Here if you see, we are just calling these things here. Okay, and we are just, this one, the plot feature importance or plot residuals. These are the functions that we have created here in the plots. The plot correlation with median house value, and plot residual, which is for finding the error between the d-valid and the predicted one. And then we have feature importance again. So it will tell us which feature is important among all the set of features. So we can identify that using this specific plot. And next, so here we have everything. So we have all the 2-3 plots: feature importance, correlation plot, residual plot. And then what we do is we store the artifact, the model that we are generating. We want to store it somewhere. So we store using xgboost.log model, and the set of parameters that we pass, the model we have to store, the artifact path, and the input example. So this is also important, right? That you should be aware of the kind of input the model is requiring. So we are sending a sample input here, and what is the format of the model, and whatever version you have to give, that you can pass it here. So once this is done, we will be just storing it here. MLFlow.get artifact URI, artifact path. This will get the logged model URI so that we can load it from the artifact store. This is for pulling the artifact path. So we have went through almost everything, right? So what we are going to do in this specific file, one is loading the data, setting up the MLFlow, and then training the model and tracking the changes that is happening in the model's performance by using callback. And then we are creating an objective for the Optuna. Okay, so whatever that objective is, nothing but keeping track of all the parameters and then finding the best parameter out of it. So that is our objective. So we'll be calling that particular objective here. Okay, while creating a study, we'll create a study object, and then study object will be connected with the objective function, the trials, number of trials that you want to do, and the callbacks you have to make while you are trying to optimize your objective function. And then we are logging everything again. So with that, what I'll do is, this is already running, right, MLFlow. So let me go here, run it here, like 127.5000, right? Yeah. So I already have one experiment already done here. Let me see if I can change it. Optuna trials run name. Okay. Let me change if I already have this MLFlow Optuna trials. Okay, so it is already there. Okay, so what I'll do is I'll just modify it. MLFlow Hyperparameter tuning. Okay, so this is done. So just let me just run this. Okay, I'll go to this another terminal here, change it to MLFlow Optuna, and then clear this Python 3 training.py. Okay, let me run this here. So it will kickstart quickly. So where are we? So it created the correlation plot here. Okay, if I go back here in the training.py, you will be seeing this line right here, correlation plot. The saving path is correlation plot.png. So it created here, and we are able to see the correlation, which is 0.6 for a specific feature. For median income, this is the maximum correlation with the median house value. So greater the income you have, greater the median house value is. Okay, so greater the average number of rooms, greater will be the house value. Again, less number of house age, okay, greater the house value. Okay, so these are like negative correlation in a sense. Okay, so now what we are seeing here, right, these are number of experiments that is happening, the number of trials that we gave here in the training.py. If you see in the objective function, we mentioned something called as trials, number of trials that we want to do. So where it is, I guess it is here, right, some parameters that we have set. Yeah, so if you see study, okay, under optimize, number of trials is 500. Okay, so it has run 500 experiments, okay, on different parameters, on range of values each parameter can take. So it is running and it's still running. Okay, let me go to here. Okay, let me refresh this one. I think this will be, it is told, okay, it's up and running. So Optuna trials, it is not coming up here. So let me see here, we have 1 minute ago, I think this is the one. So it was created 1 minute ago, and let me see here, what was the, Okay, this created this one. Okay, this is the run. This is the experiment name. Okay, it is not there. It will create. Go ahead and create, and then we'll get the experiment ID. So if it is passed here, okay, that's fine. But I guess I missed out somewhere updating the run name here. So run name is Optuna trials, right? Optuna trials, exactly. It's correct. So yeah, it is getting refreshed also, right? This is the same experiment, I guess. Let me refresh. Maybe it has picked up the old name, I guess. It was not saved, maybe. Okay, this specific whatever that experiment name that I gave, I think it's not updated and it took the old value. Okay, that's fine. So we have already like executed almost, right? It has got completed also. The 500 trials are done. Okay, we are already able to see all the trials here, and if it keeps getting refreshed also, 25 experiments are added. So all these things are there. Now what we have to do is we can understand the best model from here. Okay, just Optuna trials. Okay, and if you see, this is the best MSC and RMSC. Okay, if I go to model metrics, okay, this is how it will look like, and artifacts will be stored here. The important part, right? So what people don't give much importance, right? Understanding these parts, the data type of your inputs. Okay, because what will happen is when you're trying to do inference using like in production environment, you want to ensure that you have all these data types being followed, and because it will throw an error otherwise. Okay, so it has to match A to A. Okay, so that's there. And then we are seeing all the plots here. Okay, this is the correlation plot, okay, between all the features and the target variable. Feature importance. So median income has the maximum importance, 98.74, and all other has some lesser, like drastically less number of importance. This is the residual plot. Okay, so we have error between -4 to +4, I guess, if I'm not wrong. Okay, so this is around 4 and it is nearly 2. Yeah, it's around -3. Yeah, so that's that. And then let me go back here and here. Yeah, if you see here, what are the different parameters that we are looking into, right? So we have tried out GB tree. Okay, there was some other parameter that we were looking into, which was GB tree along with DART. And then we have grow policy, loss guide. Alpha value is this one, and maximum depth is 7. Gamma is this one. ETA is this. And then let me go back here and let me click this graph. Okay, let me select. Okay, first let me select this one and then select this graph. So this is the best MSC, which is 0.25. Best RMSC is this one. These are the values different trials have given, and these are different values for different trials. And then if you want to do something like filtration, right, what you can do is params dot booster. I want to look into only GB tree. Okay, so I'll just run that and it will filter me everything with respect to GB tree. And then this is 0.25, right? Okay, this is for GB tree. Let me turn that to Dart, right? Okay, Dart. This is the best one, and these are some other Dart based Dart approach, right? These are Dart. Okay, so what was the value for that? Okay, we are able to see those here. So there is so many things that are happening, right? Okay, so here you have this model. Okay, all these details are present. What is the input sample that is required? What is the basic requirement for this to run? Python environment file, model UBG format, input JSON, conda YAML, like the dependencies are mentioned here. This is our model, ML model. So yeah, so what we have seen in this video, right? Okay, if I just have to do a quick review of what we have done. We have integrated Optuna with MLFlow. Okay, we trained a model, XGBoost model. There are different parameters of XGBoost which we try to do hyperparameterization on. And once that is done, we were able to track the experiments on the MLFlow. There are like hundreds of trials have happened. We were able to look into each of them. We can look into different parameters like by using the filters that we have here, and then we can also plot. We can look at the plots. Okay, so those things are available here. So yeah, so we are almost done with what MLFlow with Optuna. Okay, key part once again, key part is objective function. Okay, the parameters that you have to hyperparameterize, and then you have something called as optuna.createStudy and study.optimize. These are some very important lines that you have to remember if you're just starting with Optuna. Okay, so with that, I'll conclude this video. Thank you for watching. Bye.